Okay, we're going to start with number 26, going over our study guide. Number 26, we need to add the corresponding parts of these matrices together. And when we do that, 5.9 plus negative 3.7 is 2.2. Negative 18 plus 3 is negative 15. 18 minus 9 is 9. And negative 4.2 plus 3.9 is negative 0.3. So that's our answer for number 26. Number 27. Look at 27 and 28 together on this piece of paper. 27 says negative 2 to the 5th power. 28 says negative 5 to the 4th power. Be careful that you understand what they're asking for. They're asking you to use negative 2 5 times. So that is negative 2 times negative 2, which becomes 4, times negative 2 times negative 2 times negative 2. 4 times negative 2 is negative 8, times negative 2 times negative 2. This is 16 times negative 2, and then that's negative 32. The negative got used every single time that the number did. I had 5 of them, so I ended up with a negative answer because I had one extra. Every time you make a negative pair when you're multiplying, it's going to be a positive. That one extra caused it to be negative. Now, 28 is a different kind of problem. They do not want you to use the negative every time you use the number. They want you to think of this as negative 1 times 5 to the 4th. So you're using 5 4 times and you're multiplying it by negative 1. If you want to go ahead and find 5 to the 4th on your calculator, that's fine. It's 625. Don't forget you have to multiply by negative 1, so the answer is negative 625. Now let's look at what these would look like on our calculator. Your calculator will do the right thing if you tell it the right thing. So you take negative 2 to the 5th power. It'll give you the right answer of negative 32. You enter negative 5 to the 4th power. It'll give you the right answer of negative 625. It's your job to be very careful about entering these negative signs with or without their parentheses. 29 says 13 times 6 squared divided by 5 squared minus 4 squared plus 9. So we start here, and the first thing we're going to do are the exponents. So it's 13 times 36 divided by 25 minus 16 plus 9. 13 times 36 divided by 25 minus 16, which is 9 plus 9. Now do the division first. 13 times 4 plus 9. So this is 13 times 13. And the answer to number 29 is 169. Number 30. Number 30 says write these in order from least to greatest. Well, first of all, you know that this one's negative and this one's negative. Let's make them all have the same denominator. Negative 1 6. If you take 3 times 2 is 6, so 5 times 2 is 10, and then negative 5 6. If they have the same denominator, then you order them according to their numerators. And since negative 5 is smaller than negative 1 because you're on the negative side, you have negative 5 6, negative 1 6, and then 10 6. This is number 30. 31 says you made 2 deposits to your bank account this month. One was for $17.92. The second was for $15.33. Your balance at the end of the month is $72.31. You made no withdrawals. Write and evaluate an expression for your balance at the beginning of the month. The beginning of the month, add $17.92, add $15.33. You're going to end up with $72.31. You didn't take any money out, so you take the beginning of the month, You add your two deposits, it should equal your new balance. Combine like terms, $17.92 plus $15.33. So we get the beginning of the month plus $33.25 is $72.31. Subtract $33.25. The beginning of the month is $72.31 minus $33.25. $39.06 is your answer for 31. 32. Where are we at? Name the property. If you multiply by 1, you get the same number back. That is the identity property of multiplication. 33, what can you add to something and get the same thing back? What number can you add to x and get x back? 0 is that number. That is the identity property. This time of addition. 34 says 8 times 1/8 is 1. What do you multiply by and come out with 1 for an answer? It's called the inverse property of multiplication. 35, what do you add together and get 0? Inverse property of addition. 36 says write an equation to show how the amount of money in a jar of nickels is related to the number of nickels in the jar. Well, I know that an N is the number of nickels. The nickels are worth 0.5 cents. So N times 0.05 would be the amount of money M. If the jar contains 40 nickels, I'm sorry, there it is so you can see it. If the jar contains 40 nickels, how much money is that? $2. $37, simplify the following expressions. -1 to the first power, -1 to the second power, -1 to the third power, -1 to the fourth power, -1 to the fifth power. -1 to the first power is -1, just is what it is. -1 squared means you're going to multiply -1 together twice. You're going to get +1. -1 to the third power is -1 times -1 times -1. Well, you've already done this problem. Its answer was 1 times -1 gives me -1 again. Now -1 to the fourth. So I get 1 times -1 times -1. So I get -1 times -1, which is 1. And -1 to the fifth power, if you do this and multiply it by -1 one more time, you get -1. What is the sign of the final answer when the exponent is odd? Odd exponent. When you have -1, means that you are going to have a negative answer. When the exponent is even, you're going to have a positive answer. So -1 to the 19th is -1. 38 asks you to justify each step. The first thing we did in 38 was the distributive property. We've talked briefly about that, but that's what that is. The next step, we subtracted. So the first one was distribute. the next thing we did was we rearranged, so we commutative property of addition, because we're adding, not multiplying. Then we took the x out, so that's the distributive property again, and then we just added, and we added again, and then we used the commutative property of addition. I want you to circle that one. We've not covered enough for that to be on the test, so just circle that. I want you to write that down, but don't worry, that won't be part of your test. Simplify the expression, justify each step. That comes on the later section as well. Is the statement below true or false? All real numbers are rational. That one is false, because irrational numbers are real as well. Real numbers consist of rational and irrational. Is the following statement true or false for all values of a and b? If false, give a counterexample. When would a plus b be greater than b? When would a plus b be greater than b? Well, if a is positive and b is positive and you add them together, it's always going to be greater than the absolute value of b. But if a is negative and you add it to positive b, it's not going to be greater than. Or if b is negative, you're going to get a smaller number in there. So anytime the signs are a is negative or b is negative or both is negative. If they're both negative, you're going to be in this situation. But if one of them's negative and one of them's positive, we're going to be in one of these situations.